Hey guys, so today we're going to be talking about vertex form for quadratic functions. Now at the top we have transformations. All that means is we are going to be writing a quadratic function that is not the parent function, and we're using vertex form. So if you remember from the last video of key features, our vertex is written in the form of hk, and our axis of symmetry is x equals h. Okay, so the first thing we have on here is that we can see the parent function. This is f of x equals x squared. That means that's what a quadratic function looks like when it goes through the origin and has an a value of 1. So our a is going to tell us how wide or narrow the parabola is. And I'm going to change that. Which way it opens. So what we mean by that is we're going to see if it's wide or narrow, and we're going to notice if our arrows are going to point up or point down. So for our wide and narrow, we're going to have the absolute value of a is greater than 1. And what that means is just the number disregarding the positive or negative. We don't really care about the positive or negative for this purpose right now. If a is greater than 1, then it is narrower than the parent function. Okay, that would be like this. Okay, we also call that a vertical stretch or a horizontal compression. And the reason we say that is if we stretch something out, it gets longer. So if we stretch it in the vertical direction, it gets skinnier and taller. And if we were to compress something, that means it gets smaller or squished. If we squish it from the sides, it will do the same thing. So if the absolute value of a is less than 1, it's wider. Again, just because -5 is less than 1, that doesn't mean the graph would be wider. 5 is greater than 1, and so therefore it would be a narrower. And the way a wider one would look is like this. And these aren't perfect. They're just examples. All right, so the other thing I said we could find out from A is whether it points up or down, opens up or opens down. So if A is positive, it is concave up. Which looks like a smile. If A is negative, it's concave down. It looks like a frown. Down and frown rhyme. That's one way to remember it. All right, so the next letters that we need to worry about are H and K. So H tells us that we're shifting in a horizontal direction. And that means we're changing the X value. So one thing we need to remember is that because it is minus in the original formula, we're going to use the opposite for figuring out our vertex from an equation. So if we have x minus h, that gives us a positive x. So that would be, if we were to move it this way, and if we have x plus h, we have a negative And the x here, of course, refers to the vertex. So that would be like this. So we remember from when we did linear transformations, when we moved it left and right, up and down, h was our left and right, and we said insiders lie. The numbers inside the parentheses will lie to you in this case. And so the last one is k, over here. K is going to be our vertical, and that's going to change our y value. Now with k, it's just going to be, as you see it, a positive k equals a positive y. And a negative k is a negative y. So for negative, that would mean we shifted it down. And mine are not perfect, but we're just doing this as an example. And for positive, we shifted it up. So that's what we need to know. This is a basic cheat sheet of what you need to know about vertex form. Now we're going to see how we can turn information into vertex form. So from a graph, it's reasonably easy. You just find the vertex and two other points, run it through a quadratic regression, and you're good. We need 3 points. So here we have, what does a quadratic function look like in vertex form? It's going to be f of x equals a x minus h squared plus k. And which of these is written in vertex form? That's going to be b and d. For d, a is -1. So now we have given a point on the graph and a vertex of hk. We want to write the quadratic equation in vertex form. We are given 2 points. We have a given point and a vertex. We need a third point. The way we find that third point is by finding a symmetrical point to the, quote, given point. So we need a third one. So we're going to make a list. We need an A, we need H, we need K. We already know H, which is 4, and K, which is 1. We need to find a third point. So what we can do is we can take a table, put our first point, and then our vertex, and we'll always stick the vertex in the middle, and we're going to keep the same y value as our first point. And then we just ask ourselves, how did I get from 5 to 4? Well, to get from 5 to 4, I subtract 1. So to move to the next point, I'm going to do the same thing. So this is going to be 3. All right, so I can use these 3 points to determine A, and to do that, I'm going to use my Inspire. And I'm going to add a list in spreadsheets because I made a list of points. And I'm going to put X in my A column, and I'm going to put Y in the B column. And then I'm just going to fill in the points I had. I had 5, 4, and 3. And then I had 4, 1, and 4. And then what I'm going to do is I'm going to hit Menu. I'm going to go to Statistics, which is option 4. I'm going to go to Stat Calculations, which is option 1. And I'm going to do a quadratic regression. I am going to go ahead and tell my calculator that my X list is located in the column with X. And all my Y's are in the column I labeled Y. And then in the Inspire, I like to go ahead and scroll down and make sure that my first result column is not A or B, because I do not want to override the data I have, simply because I can just change the numbers as I go. I do not have to do a quadratic regression every single problem. If I'm doing multiple quadratic regressions using an Inspire, I only have to do the quadratic regression process once. I can just change the points that are there. So I hit OK, and it tells me that my A is equal to 3. So I'm going to put that on my list. And then all I'm going to do is plug these 3 values into my formula. So we had f of x is equal to a x minus h squared plus k. And so our a is 3, h is 4, k is 1. And that's all we needed to do there. So we're going to do the same thing for number 2. We have our given point, 4, 4. We have our vertex, 2, 6. So we need to find our A. We have an H, and we have a K. So our H is 2, K is 6. And let's make our table, X and Y. We have 4, 4, 2, 6, and some number and 4. So from 4 to 2, I subtract 2. So do it again, subtract 2, and I get 0. So I'm going to go ahead and change these points in my calculator and use the information it gives me. So as I change the points, and I'm going to go ahead and change this one first so it doesn't give me an error, because if I were to change the first one first, it would say that there was an error because, remember, in a function, every x can only have one y. So I can't have two x's on a parabola that have different values. Okay, can't have the same x twice. So this gives me a equals negative 0.5. I prefer fractions, so I'm going to put negative 1 over 2 because 0.5 is the same thing as 1/2. And we're going to plug that into our formula. F of x equals negative 1/2 x minus 2 squared plus 6. And that is really all there is to it. It's not that difficult. As long as you know what symmetrical points are, what your pattern looks like, you will not have a problem. But if you have any questions, feel free to leave them in the comments down below, and I'll see you next time. Bye.